busy here. So, little bit of refresher from yesterday. We're looking, and we've got a whole bunch of them here in part number 4. We've got a whole bunch of problems that deal with the inverse functions. So remember, there are 3 inverse functions that are defined in quadrants 1 and 4, and there are 3 that are defined in quadrants 1 and 2. Does anybody remember which of the inverse functions are 1 and 4? And that means negative 90 to positive 90, okay? Which one is it? Inverse sine, inverse tangent, inverse cosecant. So any problem in this whole list, any problem that has those, the answer to the problem is going to be between negative 90 and 90, or in radians, I think these are supposed to be in radians, between pi over 2 and negative pi over 2. All right? Then, what are the 3 functions defined in quadrants? Inverse functions defined in quadrants 1 and 2. Well, it would be the other 3, right? So it's cosine, cotangent, and secant. Now, this is key. This is the hardest part, because you know how to do everything else. So here we go. Problem B says find the angle whose sine is 1 over root 2 negative. All right? So I want you, when your eyeballs see this, I want you to immediately think exactly what I said. Find the angle whose sine is negative 1 over root 2. That's what you're doing. You're going to find an angle. And since it's an inverse sine, you're going to look in quadrants 1 and 4. Since the sine is a negative number, it's not going to be quadrant 1, so you're going to look in quadrant 4. So here's your quadrant 4 triangle. The sine opposite over hypotenuse. Okay, this is no calculator, so you better be able to recognize that. Do you recognize that? How big is that angle right there? 45, which in radians is pi over 4, half of 90, pi over 4. So what do we put down in the answer blank? Negative pi over 4. Now, kids, if you wrote pi over 4 as the answer, which quadrant is pi over 4 in? Quadrant 1. What's the wrong quadrant? We have to be between negative pi over 2 and positive pi over 2. The only way we can be negative is to be over here. Perfect. All right. Next. The angle whose tangent is 0. Now, zeros and ones are always kind of different, because you'll kind of recall a lot of times those are what we call the quadrantal angles. But let's think about this. Now, we're an inverse tangent. So we are in this part of the circle. Would you agree with me? Quadrants 1 and 4. Just like this one was. Now, I'm not going to be able to draw a triangle that has a side of 0. So that means on my triangle, or on my picture here, I'm going to look at this point, and this point. So 0, 1, 1, 0, and negative 1, 0. Which of those angles, does everybody understand a triangle is not possible, right? So that's why I'm looking at my quadrantal angles. Which of those quadrantal angles would have a tangent of 0? Which one are you pointing at, Sarah?
0, 1.
This one right here. This one. Why does that one have a tangent of 0?
Because your tangent would be your y over r.
Y over x?
Yeah.
Y over x? Tangent is y over x. Oh my gosh, if you've forgotten that stuff, remember it. Tangent is y over x. So if you put, look Sarah, if I put y over x, I don't get 0, I get undefined, don't I?
I labeled my 2 points wrong.
Okay. I wouldn't admit that out loud. So 0 over 1 is 0. What angle is this right here?
0.
0. So the answer to the problem is 0 radians. The angle whose tangent is 0 is 0. Oh, here's another one. The angle whose cosine is 0. Now, again, you are not going to be able to draw a triangle whose adjacent side is 0. That is not going to happen. So you are going to have to look at your quadrantal angles again. But this time, this is cosine. So this time, aren't we looking at this part of the circle? Quadrants 1 and 2. So this is 1, 0, 0, 1, negative 1, 0. Where in that scenario is the cosine, which is x over r? Where is that 0? Straight up, right? What angle is that? In radians? Pi over 2. So your angle is pi over 2. Perfect. Lucy,
Never mind. I don't like the question.
you got it figured out?
Well, okay, no. I'm gonna ask it anyways.
Yep.
So like for the 0, I don't know if this makes sense, but I thought instead of 0 is gonna be 2 pi because it's like all the way around the circle you get back there. But is that if it was the whole angle?
Well, I'm not sure 2 pi isn't really involved in this problem because at 2 pi,
No, the other one, the tangent, the inverse of tangent one.
oh, over here?
Yeah.
Oh, okay. Yes, 2 pi would be another answer. The problem is, with this notation, you are restricted to these values. Is 2 pi in there? No. So, Lucy, again, we talked about this a lot before, that there are lots of answers to all these problems. 0, 2 pi, 4 pi, negative 6 pi. There would be millions of answers. The inverse functions have made it so there can only be one.
Okay.
And 2 pi is never going to be an answer to one of these problems because it doesn't fit in either, well, I didn't write this one down, but it doesn't fit in either range.
Okay.
Got it?
Mm-hmm.
Okay. All right, try E on your own. See what you can do with E. Now, you will be able to draw a triangle if you wish. So cosine 1/2. You'll be able to draw a triangle if you wish. Those of you who use your unit circle, make sure you're looking in quadrant 1. Because your only options are 1 and 2. And that's a positive number, so it has to be 1. So cosine is 1/2. What's the angle associated with that? 60 degrees, which is how many radians? Pi over 3. 60 is a third of 180. So pi over 3. Now I want to go back to what Lucy was talking about because there is kind of a distinction here. If I were solving this equation, Lucy, I would get cosine equals 1/2, right? If my directions were what they usually are, which is all the way around the circle, then I would have multiple answers. This would be one of them. but I would also have one down here. So it's kind of the same problem, but because this one is written with this specific notation, I am locked in to that one spot. Got it?
Yeah.
Okay. All right, next. You haven't done yet? Yeah, it's supposed to. I didn't write it right. So Leah figured out. It's supposed to have the inverse notation. I'll have to fix that. Not a trick question, just trying to figure it out. All right, so I'm gonna draw a triangle. Where am I drawing it? Quadrant what?
4.
4. Got it. Good. 4. Tangent is opposite over adjacent. Isn't this another 60?
Yeah.
Pi over 3? But it's negative 60, negative pi over 3. So the answer to the question is negative pi over 3.
Could you also write that as 5 pi over 2?
5 pi over 3. 5 pi over 3 would be drawn in that same spot. But this comes back to what Lucy was asking. Any answer to this problem must be written in this interval.
Oh yeah.
Okay?
Yeah.
So if I'm randomly solving a trigonometric equation and that's the picture, 5 pi over 3 is fine. But not with this notation. Okay? All right. Won't this one be in the same quadrant?
It's negative.
How big's that angle?
45.
45, which is negative pi over 4. Good. Tess, you following along?
Yeah.
Okay. H. Which quadrant you throwing that one in? 2. Very good. You got this. 2 is exactly the right quadrant. Why am I drawing it in quadrant 2? Because it's a negative cosine value, and cosine only exists in quadrant 1 and 2. That is inverse cosine. Only exists in quadrants 1 and 2. So, cosine, root 3 over 2. How big's this guy? He's a 30, but we'll call that pi over 6. No, there's one answer, and the only answer is not pi over 6. 5 pi over 6. Very good. And Maren, how did you get that one?
Because it would be pi minus pi.
It would be. So 6, 6 minus 1, 6. 5 pi over 6. That's exactly right.
So pi over 6 would be your reference angle?
Yep. Yep.
It's like,
All right.
no, I did. Yeah, I just
Whoa, whoa, whoa. Chris says, whoa, whoa. I had this, and now you did this. All right. Now, I want to forget this a moment. Just forget that for a second. This says, find the angle whose sine is 1/3. Okay? Now, you do not know what that angle is. I do not know what that angle is. We don't need to know that angle, but we need to know where it is. Where is the angle whose sine is positive 1/3? First quadrant. And if the sine is 1/3, wouldn't the triangle look like that?
Yes.
Now, if that had been the problem, just that, then I would need to find this angle. But that isn't the problem. The problem says, what's the cosine of that angle? So this is the angle that you just drew. And now you're going to find the cosine of it. Well, what do we need to know to find the cosine?
Side length.
We need to know the missing side, right?
Yeah. So Pythagorean
So
theorem.
what's your Pythagorean theorem say?
2 square roots of 3?
1
No.
and
2 square roots of 4.
2 square roots of 2?
Yeah.
Square root of 8? Pythagorean theorem?
Yeah.
And now what's the cosine? Adjacent over hypotenuse. So the answer to the question is 2 root 2 over 3. Okay? Now, what do we absolutely have to understand? We have to understand this notation always means angle. So this problem is asking me to find a cosine. So I drew my angle and found the cosine. Easy. All right, what's happening next? Same thing. Pretend that, who's absent today? We got somebody's absent today. Liam. All right, so you're gonna call Liam.
And, whoever sits next to him too.
Who's Josh? Oh, yeah.
Finley's not here either.
Finley's not here either. Where are all these people? So, Sabrina's here, Lillian's here, Don, Sarah, Leo, no Liam. Neely Green, are you here? Peter, Allison, Kylie, Julia, Sydney, Zoe, Alexis. Oliver is here.
Well, isn't it square root of 21?
Sarah, George.
Wait, when I did the
Macaulay.
because I did -2 squared. Yeah, I think.
All right. All right, so we're gonna call one of these absent people. And they can't see anything, we don't have a computer, we're actually like talking to them on the phone. How are you gonna read this problem to them on the phone? You're not gonna say tangent cosine -1 -2/5. That's not what we're saying. What does this problem mean, Sammy?
The tangent of the inverse cosine of -2/5.
Tangent of the angle, which is inverse cosine, whose cosine is -2/5. That's what we're gonna do. We're gonna find a tangent of an angle whose cosine is -2/5. So the first thing we're gonna do is draw a picture of this angle. Where are we drawing it? Quadrant what? Cosines. Oh. Remember, cosine is 1 and 2. Since it's negative, it has to be 2. Cosine is -2/5. This would be the square root of something. 21, very good. By the way, I get a lot of square root of 29s in this case. Remember, when you do the Pythagorean theorem, this is C. Always. All right, so what's my tangent? -√21/2? Got it?
Is that the answer?
That's the answer. We are done. We are done.
So like, it's kind of like,
Yes.
it's like logarithms. Well, you know how a logarithm is the inverse of an exponential?
Cosine's quadrant 1 and 2.
Well, this is like that, but instead it's cosine.
I can't hear Tess. What now? -√21/2. That's the tangent. You're finding the tangent, and the tangent is opposite over adjacent. No, inverse tangent can't be, but this doesn't say inverse tangent. This says tangent. I can find a tangent anywhere. All right? All right, number 5, get your calculator out. Set it in degrees. And type in second sine negative 0.123. Put the negatives in. Normally I don't like to do that, but in these problems you have to. So second sine negative 0.123. What did you get? Negative 7.065 degrees. So the angle whose sine is negative 0.123 is negative 7.065 degrees. Okay, easy. Now for B, press exactly what it says. Press tangent, second sine, 5 divided by 8. So what you're doing is, you're doing exactly what we just did by hand. You're letting the calculator find the tangent of an angle whose sine is 5/8. Did you get 0.8006? Incredibly simple. Okay. Now, same thing, only we're going to do it in radians. So set your calculator in radians. All right, second cosine, 0.123. 1.447. Remember, that's a radian measure, so you're always going to be expecting a smaller number. You're not going to get 70 or something. You're going to get a small number. And then sine, second tangent, 1.6. 0.848, basically. Easy peasy. Number 7, find an expression for the sine of the angle whose tangent is x. What do you think?
But asking us like write it out how you would say it.
You can, you don't need to. I said it. You can write out what I said, but you don't need to. I heard somebody say draw a picture. Absolutely, draw a picture. So here's a triangle. Would you agree that this angle has a tangent of x? Would you agree with that? What would that make the hypotenuse then?
X squared, or plus 1.
So the square root of
The square root of
x squared plus 1?
Yeah.
Because 1 squared plus x squared equals hypotenuse squared. So 1 plus x squared equals hypotenuse squared. So that's going to be my hypotenuse, right? Now, I've got a picture drawn, and I want to know the sine. So what would the sine be? Opposite over hypotenuse. And don't worry about rationalizing that. You can just leave that alone. Find an expression for the cotangent of arc cosine x. Now, we talked about this yesterday. This means the same as this. The arc notation and the inverse notation mean the same thing. If we were using a textbook from when I was your age, it would look like this. Because there weren't any calculators back then. But now that we have calculators, we have that notation, so we use that now. They're exactly the same thing. So, let's draw a picture of this triangle. and it has to have a cosine of x. So would you agree there's a picture that has a cosine of x? What's the other side going to be? Be careful. What's the other side going to be?
Negative x. 1 minus.
If you
Oh,
can't do it in
sorry.
your head, write it out. So x squared plus a squared equals 1 squared, right? So x squared plus a squared equals 1. A squared equals 1 minus x squared. What is this a?
The square root of 1 minus x.
Square root of 1 minus x squared. Now, I need the cotangent. So what's cotangent? Adjacent over opposite. So my final answer is x over 1 minus the square root of 1 minus x squared. Yep.
Can we leave our answer written like that?
Yep.
Well, this is
Yep.
the cotangent of that.
Statistically.
Because this means that an angle.
Would you like us to turn in the assignment that we had over the break?
Nope.
Are we finished?
Really?
You did that for your own welfare. Did you check your answers with mine and make sure you got them all right?
No.
Okay. You didn't even do it?
No, I didn't check my
Okay. So that 4-1 to 4-6 sheet that was meant to keep you up to snuff over break, you need to do that and check your answers with mine so that you know what questions to ask. We are starting our last section. We're gonna be ready for a test real soon. Okay? All right. So here we go. 4.8. 4.7 will be due on Friday. So 4.7 is due on Friday. All right. So here we go. Those of you new to the class, I always keep the homework answers up here, so Alexis is the best at this. She'll come in the morning and just kind of check over, and then she knows what she needs to ask about. So feel free to do that, if you want. All right, 4.8. The angle of depression of a buoy. We need to understand, I think we already do, but we're talking about it again. So here's my lighthouse. I'm making this up. Here's a lighthouse, okay? And here's a buoy. So here's my lighthouse, here's my buoy. There's a guy standing in the lighthouse looking down at the buoy. This angle right here where my finger is nothing. Never. That's nothing. The angle of depression is right here. Now, the angle of depression isn't even in the triangle, so I will never draw it because the angle of depression is exactly the same as the angle of elevation because we have alternate interior angles. So my advice to you is, whether it's elevation or depression, draw it right there because they're the same. Now your angle's in the triangle and you're ready to go. So here we go. We got the lighthouse and the buoy, and the angle of depression is 6 degrees, and the lighthouse is 130 feet above the surface of the water. We want to find the distance from the base of the lighthouse to the buoy. Does that make sense to everybody?
Yeah.
This is basic right triangle trigonometry. You have a right triangle, you're allowed to assume that lighthouse, towers, all those things are straight up and down. So what function are we going to use? Sine, cosine, or tangent? Tangent 6 equals 130 over x. Caution, caution, caution. What's the unit on that 6?
Degrees.
Calculator needs to be set in degrees. So x tan 6 equals 130. So x equals 130 over tan 6. Type it in. Doesn't give me any kind of directions at all, none. So, guess what I forgot to do after I told you to do it? Did you get 1,236.87 feet?
Yes.
Perfect. From the top of a 100-foot tall hall, a man observes a car moving toward the building. So here's the man, he's looking down here, here's the car. Car's going this way, toward the building. Everybody with me? If the angle of depression of the car changes from 22 to 46 during the period of observation, how far does the car travel? Okay, so what they mean is, okay, so the guy looks down here, his angle is 22 degrees. But the car is moving. So at some point, the angle of depression is 46 degrees. And we want to ultimately know how far does the car travel. So does that picture make sense to you? Okay, so let's have some ideas on how we're going to go about answering this question. So Peter is saying, solve the pink triangle. So I'll call this A down here, the base of the big pink triangle. So we can do that. What, tan 22 equals 100 over A. So A is going to equal 100 over tan 22. I'll type that in a minute, but is that okay with everybody? All right. Then he said, do the blue triangle. So I'll call this B. So tan 46 equals 100 over B. So B equals 100 over tan 46. And then to get my answer, which is X, I'll just take pink minus blue. I got 150.94. Anybody else get that?
Yes.
So, if we could add a layer onto this problem, if we knew how long he watched, we could actually find the speed of the car. Right? Yep. Yep. All right. Interesting. Okay. Finding height above the ground. Here we go. We got a large human filled penguin. Moored at the beginning of a parade route, awaiting start of parade. Okay, so here's my penguin. 2 cables attached to the penguin make angles of 48 and 40 and are in the same plane as a perpendicular line from the penguin to the ground. So here's the perpendicular line. And this came out of your book. I didn't copy figure 4.91. But basically, one of them's 48 degrees on this side, and one of them that's what's happening. You've seen this before. So here's your big balloon. This line isn't really there. He's being held down by a wire over here and a wire over here, holding him up in the air so he don't fly away. All right, what's our job? If the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? So I guess I really do want to know that. What you absolutely cannot do is make this 5 and 5. Would you agree with that?
No, why?
Because the angles.
They might not be.
The angles are different. Aaron, this is not an isosceles triangle. So the altitude doesn't bisect the base. Now they add up to 10, but they're not the same. They're not 5 and 5. Any thoughts?
Let's start by finding the other angles in the huge right triangle.
We could definitely do that, right? If that's 48, then this one up here would have to be what, 42, and this one would have to be 50. Definitely we can do that.
Would it be like 10 divided by sine of 40? Would that get you the other side?
What other side, what are you talking about?
So then dividing in half, but if you did 10 divided by sine of 40, would that get you one of the measurements?
If you, okay, we can't really use 10 because this triangle, this is a side of this triangle, and it's not right. It's not a right triangle. So if we focus, let's just say on this right triangle, I have no idea what these are, but I might call this one, I already said X, so I might call this one A, and this one would be 10 minus A. Is that okay with everybody? So could I say, in this right triangle, tan 48 equals X over A? Now, I know I can't solve that, but is that a legit thing? All right, and then can I come over here and say tan 40 equals X over 10 minus A? And again, I can't solve it, but would you agree that's an okay statement? Now, I want to remind you what we got here. Looks a little different than first year algebra, but this is a system of equations. You have two equations and two variables. And what do? When we have a system of equations, we either substitute or we eliminate, right? So I want you to notice something. If I multiply this over here, A tan 48 equals X, and I did the same thing over here, 10 minus A tan 40 equals X. Can I set these two things equal to each other? And then, guys, we only have one variable. So A tan 48 equals 10 tan 40 minus A tan 40. So I went ahead and distributed it here. So I brought this over, distributed the tan 40. Remember, tan 40 is just a number, it's some decimal. I do not want to put that in at this point because it's rounded, I have to round it off. but it's just a number. So I'm handling the tan 40 just like I would a number, so I can distribute it. Now, I need to figure out what A is, so what would you suggest I do next? No, Lucy, that ain't gonna work, because I got an A over here too. So that, the A's have to be put on the same side of the equation. So A tan 48 plus A tan 40 equals 10 tan 40. Now that the A's are on the same side, I can factor them out. And as soon as I do that, you guys, as soon as I factor out that A, now I only have one A, and I can get it by itself by dividing by the parentheses. So A equals 10 tan 40 over tan 48 minus tan 40. Now we're not done yet, but before we go any further, let's back up and make sure everybody's on board. Leah?
Why does that become subtraction on like your third line when you take out the A?
It should be a plus, thank you. Thank you. It didn't. Well, it did, but it was supposed to. Alright, so let's back up. So the whole dilemma was that the picture with the 10 wasn't a right triangle. We're not equipped at this moment to deal with triangles that aren't right. So we made a right triangle, but then that meant this wasn't 10 anymore, so we called it A and 10 minus A. Right? Then we did each triangle, tangent, tangent. It was easiest to get X by itself, so that's what I did. I could have gotten A by itself. And then did some arithmetic and got to here. Is it okay now, Leah?
Yeah.
Okay. Now, I can type that in on my calculator. See this denominator? Gotta put it in parentheses. The calculator does the order of operations. So it's gonna divide before it adds. You need to add and then divide. So 10 tan 40 divided by parentheses tan 48 plus tan 40. What'd you get?
7.336.
Uh-oh. I didn't get that. Let me try again.
Oh, are you in? Yeah,
Maybe I
Did anyone get 7.336?
Okay. Oh, wait.
Okay, I got the same thing I got before. I got 4.3037.
Wait, what is that?
Other people got that too?
Wait,
Okay. So, that's A.
Yeah.
4.3037. Now, I'm not even really gonna write that down. I mean, I did, but I don't really need it because ultimately, what do I wanna know? X. So I'm gonna come back over here and take the answer on my calculator, which is A, and multiply it by tan 48. Now I know how tall or how far above the ground that guy is. Did you get 4.78? Took the A that I got, just multiply by tan 48. What X is, right? All right, that was a doozy. One more, here we go. I gotta erase all this. Everybody follow all that? Okay. All right, so now we're gonna do a U.S. Coast Guard patrol boat leaves Port Cleveland and averages 35 knots. Knots are nautical miles per hour, traveling for 2 hours on a course of 53 degrees. All right, stop right there. Here's my compass. Remember that the compass is labeled like this. No questions. That's how it is. That's the way the compass is labeled. He's on a course of 53 degrees. So that's going to look like this. That's 53 degrees. And he's traveling at 35 miles an hour for 2 hours. So this vector right here is 70 nautical miles. Would you agree with that? 35 miles an hour for 2 hours. All right, now he's here. Set up another compass. What direction is he going now? On a course of 143. So 143 would be down here like this. Would you agree with that, guys? 143? And he's going 3 hours on that one, so that length is going to be, I guess I'm assuming he's still going 35 miles an hour. So what is that, 105? Did everybody agree with that?
Where did you get 105?
3 hours at 35 miles an hour.
She just wrote
Oh. Distance equals rate times time. Right? What is the most bearing and distance from the original point? So basically, we want to know that right there. And we want to know this right here. Now, let's talk about what we know. Let's look right up here at this compass. If that's 53, would you agree this is 53? Alternate interior angles. And if that's 143, what's this little piece right here? 37. And the math gods are shining upon you because that makes 90, which means Pythagorean theorem and SOHCAHTOA work perfectly. So here we go. The length of that, the distance he is, we're just going to do the Pythagorean theorem. So 70 squared plus 105 squared, and square root it. I got him being 126.19 miles from port. Double check me, I've already made a mistake today, don't make any more, Leah, you keep an eye on it?
Yeah.
You got that too? All right. Now, I need, ultimately, navigational angles are measured from due north. So ultimately, I need the pink angle, but I already know the black part's 53, so if I could find the blue part, I could add it to 53. So for fun, I'm going to call that theta. That's a right triangle. So this side is opposite and this side is adjacent. So I'm going to say tan theta equals 105 over 70. Second tangent 105 divided by 70. I got 56.31 degrees. Anybody else get that? So what's his course then? His total course is 109.31 degrees. Now, boys and girls, had that magic right there not happened, we'd be in trouble at this point. In chapter 5, that won't happen, but we'll know how to handle it. We'll know how to handle
So this should always be 90, because if not, then we wouldn't know how to solve it.
it right now.
Right.
All right, got it? All right, I think that's enough for one day. Your minds are blown. I am gonna hand out